So today we're going to learn about how to solve one-step equations. The first thing that you need to know about solving one-step equations is whatever you do to one side of the equation, you have to do to the other. It's all about balancing the equation. So let's just jump right into an example with adding. So let's say we have adding adding in equations. So we have, for example, example 1, x plus 9 equals 2. So I want x to be by itself. I want this x to be by itself. So in order to get x by itself, I need to get rid of this 9. 9 is stopping it from being by itself, and between x and 9 is addition. So I need to get rid of this addition, and the opposite of addition is subtraction. So I need to subtract that same number 9 from both sides, because whatever I do to one side, I have to do to the other. So then I'm just left with, well, that's a 0, so I'm left with x equals, and it's like I have $2 in the bank, and then I'm going to withdraw $9 from the bank. And so then I would owe the bank $7. So I have -7. So x equals -7. Now I can check my answer. It's a really good idea to check your answer when you can. So I would just plug x back in to the original equation. So if I check, I'm going to plug -7 back in, and I'm going to see if this is true. I need to know if this statement is true. So let's say I owe $7 to the bank, and then I deposit $9. Well, now I have $2 extra in my bank, and 2 does equal 2, so then I know I'm correct. And that's how you check your solution. Let's look at another example with adding. So we have maybe n -30 equals 17. So here we had a positive integer, here we have a negative integer to get rid of. So I want n by itself, and the thing that's stopping n from being by itself is this -30. And between n and -30 is addition. So I need to subtract that same number. So subtract -30 from both sides. Now, subtracting a negative can be pretty confusing. So it's like I have -$30 in the bank. I owe the bank $30, and then I take away $30 of debt. It's kind of confusing, so we like to use keep, change. You're just going to keep the top the same, change the sign, change the operation below, and then change the sign of the integer. And you need to do the same thing over here. So this ends up being -30 plus 30, which is 0. So you have n left over, which is equal to 17 plus 30. So 17 plus 30 is going to be 47. And again, I can check my solution. I just plug n back into the original equation. So 47 plus -30 equals 17. Now if this confuses you with this adding a negative number, you could use keep, change here too. So 47 minus +30, which equals 17. And then when you do the subtraction, you actually will see that 17 does equal 17, or 47 minus 30 is 17, which in your solution is correct. All right, so that's kind of all you're going to see with adding. So now let's look at subtracting, if there's subtraction as the operation. Subtraction. Okay, so let's look at an example here. So example 3. Let's look at y minus 7 equals -29. So I want to get y by itself. This is the variable I'm trying to get by itself. And the thing that's stopping y from being by itself is the 7. And between the y and the 7 is the operation of subtraction. And I want to get rid of this, so I need to do the opposite of subtraction, which is addition. Now whatever I do to one side, I have to do to the other. So I'm going to add 7 to the other side as well. Then I'm left with, well, 0 over here, because -7 plus 7 is 0. And then I have y left equals, and the difference between 29 and 7 is 22. 29 is bigger, so -22. Or you can think of it like money. I owe the bank $29. I still owe them $22, so -22. And I can, of course, you should always check your answers. So just plug that y back in. So let's see, I owe the bank $22, and then I take out $7 more. Well, now I owe the bank $29. So negative 29. And negative 29 does equal negative 29, so that is correct. Then, let's look at example 4. Let's look at maybe, so we are subtracting a positive number here. Let's subtract a negative now. So m minus negative 5 equals 12. Okay? I want to get m by itself. This is my variable here. And I need to get rid of this negative 5 because I want m by itself. And the thing that's stopping m from being by itself is the negative 5. And between the m and the negative 5 is subtraction. So I need to do the opposite of subtraction. I need to add negative 5. And whatever I do to one side, I have to do to the other. So then I'm left with, this makes 0. M equals 12 minus 5, which will give you 7. And let's check our solution. So 7 minus negative 5 equals 12. And again, I don't like double negatives, so I like to use keep, change. Keep the first number, change the operation, and then change the sign of the second number. So that's change a negative to a positive, which equals 12. And 7 plus 5 is indeed 12, so then I know that I did this problem correctly. Okay? The subtraction problems you're going to get. Now let's move into multiplication. So let's look at multiplication. So I have, let's look at 9n equals 45. So I want to get n by itself. And the thing that's stopping n from being by itself is this 9. So between the 9 and the n is multiplication. So in order to undo multiplication, I need to divide 9 from both sides. And the point here is to get a 1. So it's a giant 1. I'm left with n. And then 45 divided by 9 is 5. I can again check my solution. So 9 times 5 equals 45. 9 times 5 is 45, so then I know that my answer is correct. Alright, so then, well, that was example 5. Let's look at example 6. So maybe we're going to multiply by a negative number. Let's look at 80 equals negative 8a. So I want to get a by itself this time. And what's stopping a from being by itself is this negative 8. And they're being multiplied together. So in order to undo multiplication, I need to divide from both sides. So I'm going to divide negative 8 by both sides because I want to get rid of that negative as well. This gives me a giant 1. And I also need to divide by negative 8 over here. Now I know that 80 divided by 8 is 10. But a positive divided by a negative is a negative. So then negative 10 equals a. Now I check when you have negatives involved because it's really easy to forget your negatives and then you get the wrong answers. So it's important to check, especially once you get to working with negatives. So 80 equals negative 8 times negative 10. So leave that side alone. 8 times 10 is 80, and a negative times a negative is a positive. So 80 equals 80. That is true. Okay? So those are the kinds of multiplication problems you're going to have. You're going to have positive integers and you're going to have negative integers to get rid of. Then we move into division. So when you have division problems to find the answer for. So let's look at example 7. Our first example will be x over 6 equals 5. X divided by 6 equals 5. I want x by itself. You always want to ask yourself, what do you want by itself? You want x by itself. And the thing that's stopping x from being by itself is 6. And in order to get rid of this 6, because they're being divided, is to do the opposite of division, which is multiplication. So I need to multiply the whole thing by 6. So then I'm going to have 6x over 6 equals 5 times 6. This gives me a giant 1, so I have x equals, and 5 times 6 is 30. so x equals 30. And again, I need to check it. So 36 equals 5. 30 divided by 6 is 5. So 5 equals 5 is true. Okay. Then we're going to look at example 8. Another example, maybe I have, well, sometimes we can write this as in a different way. 1/4 x equals negative 20. So this looks like multiplication, which it is, but it can also be division. And I prefer to look at it as division. So notice when you have a whole number, you need to put it over 1 and multiply straight across to multiply your fraction. So 1 times x is just x. 4 times 1 is 4, which equals negative 20. Then I can multiply everything by 4 in order to undo this division. So I have 4x fourths equals negative 20 times 4. This is a giant 1. X equals negative 20 times 4. So 20 times 4 is going to be 80, and a negative times a positive is a negative. So now I can check my answer, and I really want to check because there's negatives involved, division, it's kind of crazy. 1/4 of negative 80. Okay, so if I look at 80, let's see, if I take 80 and I divide by 4, 4 goes into 8 2 times. 4 goes into 0 0 times, so my answer is 20. And a positive times a negative is a negative, so I have negative 20 equals negative 20, which is true. And the last type of problem that you're going to get with division is when you're multiplying, or when you're dividing with negative numbers. So negative 24 equals, let's say, negative h over 3. So your variable here is negative. So we're going to multiply everything by 3. And I know that a negative times a negative is a positive, and I want this side to be positive. I just want h by itself. So I'm going to multiply by negative 3 in order to get rid of this division. Or this negative here. Not division, this negative. So I'm multiplying by negative 3 to get rid of the division and the negative at the same time. So I can multiply 24 times 3. I'll show the work for those of you who might not know that off the top of your head. 3 times 4 is 12. 3 times 2 is 6, plus 1 is 7. So 24 times 3 is 72. So a negative times a negative is a positive. So we have positive 72 equals h. Because remember, we're getting rid of this negative as well as the denominator over here. So let's check it, because we did some kind of confusing things. We want to make sure we actually did it right. Okay. Negative 72 over 3. Okay, so if I take 72 and I divide by 3, 3 goes into 7 2 times, minus 6, 1, bring down the 2. 3 goes into 12 4 times, minus 12, and that's 0, so then we can stop. So we have negative 24 equals, and a negative divided by a positive is a negative, so negative 24. Negative 24 is equal to negative 24, so this is true. So when you solve one-step equations, first you want to identify the variable that you want by yourself. What do you want by yourself? So we wanted this letter by itself. And the things that were stopping the letter from being by itself was the division of 3 and the negative. So we need to figure out how to get rid of that. So you need to do the opposite operation, which in this case was multiplication. And we wanted to get rid of that negative, so we multiply by the negative. And then perform the operation, and you will get your answer. So remember that whatever you do to one side, you have to do to the other every single time. It's all about balancing.